So we're going to take a look at the interference term in the total irradiance, and that's going to be this term right here. So to do that, we're going to start off by defining our two electric fields. And just for simplicity, we're going to go ahead and assume that there's no phase shift between them. If there is a phase shift, that will have to be incorporated into this equation. So what we're really interested in is the dot product between the two electric fields. That's essentially the heart of our interference term. And so we get this right here now. To simplify this, we're going to use a trig identity. And we've seen this trig identity before, although we used it in the reverse direction when we were talking about beats. With beats, we found that when we added these two terms together, we would get an envelope and a high frequency term. Now we're using that trig identity in reverse. So dot product. Now notice that out front here we have a dot product between the two field magnitudes. And so we've just pulled that out here, and then inside we've got the two terms that we get from combining these guys, are actually expanding them out using the trig identity. Now just a couple of things to notice. First off, this is a dot product between the two electric fields. If those two electric fields are perpendicular to one another, that interference term goes to 0. What this means is if the two electromagnetic waves have perpendicular polarizations, they do not interfere with one another. And we just end up with an irradiance that is equal to what we would kind of expect without any sort of interference, just simply the brightness of the two beams combined directly. The other thing to notice is that we actually have two terms here. The first term is going to be oscillating fairly quickly. That's oscillating at the sum of the two frequencies, whereas this term right here is oscillating at a much slower frequency, the difference between the two. So we can kind of think of this as being divided up into a fast term and then a slower term. In the next video, we'll go ahead and take a look at this in a little bit more depth.